Hello out there and welcome to this session about sockets in Java. The topics for today are first what are client-server programs, basically how are two computers communicating. We will introduce the concept of sockets. I will write the first client-server program using sockets, covering what are a socket and server socket and object streams. And then we will take a little bit, a short look about protocols. So first, a client-server setup is that we have one program running on a computer somewhere, and we define that to be the server, and then we have multiple computers running another program, the same client program, and the idea is that they want to connect to the server so that they can exchange data and information and so on. So we have a client program running on one computer and we have a server program running on another computer. The definition of sockets is taken from Oracle here. A socket is one endpoint of a two-way communication link between two programs running on the network. So that's the communication link. There's a socket on each computer in each program. This socket is bound to a port number, which we will come back to, and we have to use the IP address of the server combined with the port number the server is listening on to connect to it. So again, my server computer here has an IP address and it is currently running a program listening on a specific port number, and the client programs must then use the IP address of the server and the port number to connect to it. That's the setup. You'll learn more about network and such in a later course, so we will just skip over it here. So the concept of sockets, this is how I imagine it. If you remember these from your childhood, or maybe you didn't do them, maybe it's just my childhood, but we have two entities, a server and a client, and they're communicating across the network. In our example, we want to create, well, the first example, we want to create an echo server. So that means the client will send a message to the server, and the server will convert that message to uppercase. There we go, and return that back again. So probably the simplest program we can come up with using sockets, just to see that we can make the two programs connect to each other. So that's the introduction. Now the next step is to write our first socket program. We will just do the example that I just showed you. So first, a few concepts. We need a socket class and a server socket class. These exist in Java already, so we are going to use those. The server socket class is used on the server, and it can listen for incoming connections from a socket class on the client side. So these are the communication devices, you might say, these two classes here. So in our case, in this example, the socket communication uses TCP, which is a protocol that ensures that no data is lost. Also that everything that we send arrives in the same order that we send it. There are alternatives such as UDP sockets, but we won't look at these in this course. They are slightly less safe. Stuff may get lost, but they are, I assume, more efficient, faster. So I will swap to IntelliJ and we'll create our first socket program. There we go. I have a new project, completely empty. I will create a package. I call it echo example, and I will create a echo client, and I will create another package called echo server, and I just have to move that one. So that's a refactor. There we go. Move and I don't want it to be in here, I want it there. So I have my two, I will program the server program in here and the client program in here. Let me just move this one out of the way. Alright, we will start with the server program. I will do it very simple. I will just say I have this as a echo server. And we create a public void start method. So this is just to start the server. And in here, let's start by printing out starting server, like that. I will then put a try catch. I will wait with this. I need a try catch at some point. It's easy to do it afterwards. I create a new server socket. I'm going to listen on port 2910, and I just need to import the server socket. You can see in java.net.server socket, that's the one I want. And it's currently listening on port 2910. You can probably use many different ports. This is just a tradition based on my colleague's birthday. So yeah, I will create an instance of this. Like this, I call it server socket, that's fine. So now I have an instance, and you see this is complaining about an unhandled exception. So I will also, I can alt enter and surround with try catch. Usually I want try catch rather than the alternative, which is add exception to method signature, because then it comes up here and then someone else has to take care of the exception. So I want to try catch. That should always be your default go-to. Okay, I need some space here. So I want to accept an incoming connection. We do that by saying server socket.accept, and out of this I get a socket, and I'll just call it client socket. Maybe I just call it socket. Maybe that's enough. There we go. Let's print something out. Client connected, and from this socket I want to create an my object streams. So those streams are what we use for sending objects back and forth. So we say a new object input stream, and I give it my input stream from the socket here. And we create an instance and say in from client. So this input stream, object input streams, you have seen file streams and file readers and stuff like that. This object input stream is able to read objects that the client sends. I also need an object output stream out to client. So this one is responsible for sending objects back to the client. I create a new object output stream and I give it the socket get output stream like this. Yes. Okay, so these are my, I have my server socket. It's listening for incoming connections. Here I accept the connection from the client, so it's just waiting up here, idling. The program is stuck here until the program is stuck here in this method here until a client connects. So there's, you can imagine there's a while true loop in here that's just waiting for a client to connect. Once a client connects, a socket instance will be returned and we can continue in the next couple of lines. I create the object streams here to read and send data, and then we just need to use them. So in from client, I start by reading an object, and in my case I know I will be sending strings, so I want to send, I want to cast whatever I'm reading as a string. If I look up the documentation here on the read object, we can see that it returns an object, read an object from the input stream. Okay, so I get an object out of it and I'm casting it to a string. So I'm just calling it read. This is what we read. This one here, the client might be sending a class that the server does not know about because they're two different programs. in my case they're in the same package, but I could create an entirely different project for the client. So in that case, an exception will be thrown about we're not able to find the class on the server that the client sent. So, and I can just alt enter to collapse them into the to1 here. So they're doing the same thing. So I'm reading a string. I'm printing out something received from client like this. So we print out. I create a string to send back again, and that should be to uppercase, right? It's just in to uppercase echo server. So we send whatever the client sends, we send back again. So to sending back out to the client, I must use the out to client, this one here. We say out to client, write object, and I give it the result, and that's it. My program will then terminate here. There's nothing more to do, so that's it for my server for now. I just need a main method to start it, so I'll create a start server, start echo server, like this, and here we have a main method, and I create an echo server like this, a new one, and I call start method on it. Okay, so we could, for example, try and run this, see what happens. My qualified guess is that not much, but we do print out something. It just has to compile. Alright, so it's printing out starting server, but nothing else. And that makes sense because we print out starting server, but there's no client connected. So we are still stuck here. The server program is stuck here until a client connects. So let's make a client. And I will create a new class here in the client. I call it echo client, and we create a method public void run client. And in this one, well, I want to create a connection to the server, then we want to send a string to the server, and then we want to read the result that the server sends back again. So connect to server, send message to server, read result from server. All right. So we start from the top. In order to create the connection to the server, I need a socket. I just call it socket. Right, you see again, I have to import it. So that's imported. I create a socket, and that has to be a new socket. And here, if I press Ctrl P, you can see that, well, there are different arguments. I have to give it a string for the host IP and a port number, and I can go local host, and I have to use the port number from the echo server. So this one here, 2910, like this. Now localhost is just a shorthand for the home address. So your computer's own IP, if you connect to it, is this. If, however, you want to connect to another student's, then you can go to find your own IP address. You can Windows key. How do I find this? The shortcut is Windows key R, command prompt, like this, and I can go IP config, and it will then show me the IP address. And when you are on campus, this one here, IPv4 address, should start with 10, and that's your wireless IP address. So that's the one you can copy that and insert here. You know, whatever it was, like that, and connect to another student's computer. But in my case, I'm running the server on the same computer, so I can just type in localhost, which is equivalent to the local address. This one is complaining about an IO exception. These exceptions are thrown if we cannot connect to the server. Sometimes there's a connection error, your internet might be out, the server is not running, or what do I know. So again, surround with try catch. I just print the stack trace if needed. I will just remove this, put it down here. Like, that didn't go well. Maybe I will put it over here. Okay, so like this. So everything is going inside the try catch. So that's well, that's basically connecting to the server. If this creation here succeeds, we receive a socket instance, and that has a connection to the server. I then need my object output and input streams, and sometimes, but apparently not always, but usually I have to create them in opposite order as I do on the server. So here I created an input stream first, and that has to get a matching output stream on the client side. So I will create an output stream first, like this. First the output stream, and then we create an object input stream, and I just rename this out to server. So this is used to send to server, and here we say in from server, and this is equal to a new input stream, and from the socket we get the input stream. So first the output stream, which matches that first the input stream on the server side, then the output stream on the server side, which matches the input stream on the client side. This is probably not necessary when you do multi-threading in the next session, but I have seen some students where their program are stuck because they are not connected, created in this approach here. So these are my communication devices. I am now ready to send a message to the server. We will say out to server, write object, I'll just say hello. I could read from keyboard here, or console. I could do that, maybe we'll do that later. So I'm sending out to server, and we know that the server will then send something back to the client. So let's do that. In from server, read object. And this one, again, it might throw a class not found exception, so I have to add a catch clause down here, and I can just collapse them all enter like this. And I know that we are getting, like that, we're getting a string back again, so I'm casting it. And I'm pressing, I'm putting the cursor here at the end, I'm pressing Control Alt V, and that will give me the auto assign the left side here. We'll just say result, and then we print out the result from server like this. So I create the connection, I create my streams, I write something to the server, and I read something back from the server and print it out. So let's see what happens. I will start the echo server. And I still need some more way to start the client here. I'll need a main method, new class, we call it run start echo client, like this. And I need a main method, and I need an echo client like this, and we call run client on it, like that. Echo server, let's start the server, not in that one, here. So we just need to compile everything again. Yeah. Okay, so let me just first start by showing. So I have one server running down here. If I try to run another one, well, first it says I cannot run the same program twice. Okay, so we're going to need this. I will show you again later, but you might as well see it here because then you see it more times and maybe you can remember. If I want to run the program more than twice, I go up here. I want to edit run configurations. I find the program that I want to run more than once, and I say allow parallel run. Okay, now I can start another instance, and I just wanted to show you because this is a common mistake. I get an exception here, and it says address already in use. Get a bind exception, and that's because I'm trying to use a port that I already have a running program that's using, so I cannot have two programs here using the same port. So this often people forget that you can see here I do actually have something running, but if I have another tab open and people go and try and start the server again, and they will get this message here and they're not sure why. But this button up here, that is going to terminate all. So this is the end all button. Okay, that was a bit of a sidestep. We'll run the server. It's starting a server. I will run a client. Do that here. And well, I get hello back from the client. Right, in my client we send hello, and I'm getting back from the server a result. In my server I have a client connected. So client connected, I am receiving something, hello, and then we write the result back again. Alright, so that's the first simple few steps. You'll see that both my server and my client has terminated. Often we want to, well, basically always we want the server to keep running, not just serve one client and then terminate. So the simple solution to that is to make sure that I have a while true, so that the server keeps doing whatever it needs to do. I'll put it here like this. Okay, so now I do initially start a server socket. I just need to do that once. We are waiting for the client to accept, for the client to connect and the server to accept the connection here. Whenever a client connects, we get the socket, we do the streams, we handle the socket, and then we start over. So that connection is now terminated. So that means my server will keep running and it will be able to accept clients one after the other. So let's try again and see what happens. Yeah, and I can run my client. I get hello, the client terminates, no longer running, but the server is still running. So let's try again. And the server is, handling. So now it handles two clients, and it will continue handling clients until we terminate. The next part is, we'll discuss this in the next video, but I want to show you just a problem here, because we can only handle one client at a time. I am accepting, so my program is stuck here in the server until a client connects. The next place here is that we want to read something, so it's actually also stuck here until the client inserts something, and the client sends something. So there are two places. We're stuck here until the client does something by connecting, and we're stuck here until the client sends something. And that means our program is waiting for one specific client, and we cannot handle multiple clients at the same time. But we saw that a client server system in my wonderful diagram here is supposed to be able to handle multiple clients. And we will look at this in the next session by making the server multi-threaded, but I just want to show you the problem here before we move on. So if I go to my Echo client and actually do this here, I will say I need to read from the console, and I forgot how to do that. Hang on. Alright, so you will probably learn at some point there's some things that you're going to do quite a lot in when you write Java programs, but you never remember how to actually do it, so you have to Google that every time. Okay, so I want to create a new scanner. We are reading from the system in, meaning the console. I need a new instance, Control Alt V, having placed my cursor down here, my caret. scanner, and I say scanner dot next line. That's going to give me a string, s whatever, and we're sending that to the server. So the difference now is that my client program is stuck here. Let's just say print something out, connected, and like this. And then it's waiting for me to actually type something in. And once I have typed something in here, it will send it to the server. So my client is waiting here, and my server is waiting for me to type something in. Okay, so let's see what happens. All right, my server started. We will start my client, and I can type something in. Good day. And I actually get a response back, and my client terminates. Okay, so that still works. I haven't broken anything. Let's try again. I start my client, and it's waiting for me to type something in, and we can see that I have a new client connected. So now I want to run a second client, and I have to allow this to run in parallel. So I go up here and I say configurations, and I find my start echo client. I say allow run parallel, allow parallel run, and we try again. And my client says that it is connected, which is sort of, well, I have sort of a connection, but I'm not down here yet. So we're still stuck on trying to create these. We're not actually, I only have one connected here. That was from previous. So I sort of only have one client that's waiting for me to type something in. I cannot type anything in here. So that's because the server is, waiting to read from the first client, and I'm connecting to the second client, but it sort of has to wait up here until we handle the first one, and then we go back up and handle the second one. So you will see that my second client is connected. If I finish here, my second client will then activate and get its turn. My client terminates, and now I can put in here. Right? I can insert a message. So my clients are waiting their turns. One client is handled at a time, and obviously this is not a good approach if you have many clients trying to use the server. So in the next session, we're going to make a multi-threaded server so that we can handle multiple clients in parallel. All right, let's jump back to the, no, before we do that, I just want to put this on GitHub. So version control system, or whatever it's called, import into version. I share a project on GitHub, and I want to log in with username. I probably have a password. Let's see. And so this is how I'm sharing a project on GitHub. For when you do this for the semester project, you should do that fairly early, because, well, before you add too many classes. But you do need to have one class. Folders cannot be added, I think. Circuit videos, that's probably fine. So I'm going to put my examples from the videos in here, and then you can find them on GitHub. So I'm pressing the share button, and it's doing its stuff. And it's asking me, what do I actually want to commit to GitHub? And by default, I only want to commit stuff that is inside the source folder, the SRC. The others here are not used. There's some specific settings for IntelliJ for my computer. Those are usually not, you don't need to commit those. My experience is they tend to change whenever someone changes part of the code, and then you have to redo your project and kind of stuff. So I suggest just doing your Java classes. So add those. And we're just waiting it for push to GitHub. Yep. And that should be it. All right. So My project is now on GitHub, and we can just go and take a look. I have a bunch of repositories, a bunch of examples by now, socket videos, it's right here. And I can go and take a look at the code. Right. Your client, github.com/Troels-Mortensen. That will get you to the front page here. Okay. Let me find my presentation again. So my presentation contains this. I will put it up also on its learning, I assume. There is a comment about, you saw that I used the method write object, and this one does some internal caching. So if you're sending, I've only seen the problem if you're sending an array list, then sometimes you want to send a new array list, but you're receiving the old one on the client side or on the server side. Then you can use write on shared instead. Then it will actually send the new array list every time. I think it's only a problem for the next session, because after that you're going to send classes containing the array list, and then it will not be a problem anymore. Okay, so my slideshow from, well, it's the one from last semester, so it has a bunch of comments about the code we went through. But we will skip to here and talk a bit about what is a protocol. So a protocol is a schematic for how the client and the server communicates. Now you mainly need these protocols for this session because there's a specific order to things. When we move forward, it's less relevant, but it's still nice to know about protocols. What are they? You will encounter these in the future one way or the other. So a protocol, a schematic for the communication. In my simple echo server, we saw that the client would send hello to the server, and the server would send hello back again. So I'm drawing these lines to indicate that the client writes an object and the server will then read the object. And the next step is that the server writes an object and the client reads an object, and so on. Because an often common mistake that I see when my students are doing the exercises is that some of the more complicated exercises you have to send data back and forth a couple of times, and they mess up the protocol. So the client is reading at the same time as the server is reading. So they haven't drawn this specifically, and they are not sure about the specific order of reading and writing, that they match the specific order of writing and reading on the server side. So this kind of diagram can help you. If I take another example, my client will initially connect. My server could say, send a string back, how can I help you? So that means the client should expect to read an object. The client can say, I want to convert something to either uppercase or lowercase. So here I'm giving options. The server will then ask, what is it you want to convert? The client will send the string. The server will do the conversion. So it's a slightly more complicated, but not much, echo example. So the server is sending the result back again. Now this here, I could put that in a loop. So I say the client should keep doing this, and the server should then keep expecting this until at some point where the client sends the stop message, and that will terminate the client, and it will make the server go back and expect the next client. So this means that I still have my while true in the server, and I have a while loop to represent these here also on the client side. So a slightly more complicated example, and you have to be more precise in when you read and when you write objects back and forth between the server and the client. Make sure that your order of things are correct. All right. We talked about places in the code where the program was waiting for something to happen. Either the client connects to the server, so that was the server.accept. server socket.accept, or when we are reading an object either on the client side or on the server side. And we also saw that it blocked interaction with other clients. So next time we're going to take a look at how to solve this using multi-threading. And that's all for this introduction of sockets in Java. Thank you for watching.